guys, and welcome to your lesson on inductive reasoning. This is not to be confused with deductive reasoning. We will talk about deductive reasoning very soon, but for today we're going to be talking about inductive reasoning. Now, inductive reasoning is all about patterns, seeing a pattern of events and then saying, oh, I understand that this is happening, or making a statement based on what you always see. So, for example, you could say, okay, well, we were in school on Monday, and then last Monday we were in school, and then next Monday we'll be in school. You could say that we're in school every Monday. So you made a conjecture based on what you saw, with a pattern of events. However, your conjecture could be either true or false. So I could prove it wrong by saying, hey, what about MLK Day? Or what about Labor Day? Those are all Mondays that we're not in school. So by providing that counterexample, I proved the conjecture false. So that's all what we're going to talk about today. But before we get into the heavy stuff, let's go ahead and start out with finding some patterns. So taking a look here, we have a pattern of events, January, March, and May. What I'm noticing here is that I'm skipping a month. So January, but not February, March, but not April, May, but not June, so the next answer should be July. On this one, all we're doing is adding 7 each time. So add 7, add 7, add 7. So basically what's happening here is some people might think, oh, I'm multiplying by 2. Well, if I multiply 14 by 2, I don't get 21. So you have to find the accurate pattern. So when I add 7 to 28, you get 35. So patterns is not always about months and numbers. Sometimes it can be about shapes. So taking a look here at these triangles as they point in different directions. This is points up, left, down. Basically what's happening is it's turning counterclockwise. So the next picture needs to actually point to the right. So this kind of actually reminds me of like a video game controller, up, down, left, right. You know, you're hitting, a secret code, A, B, A, B, This is what it kind of reminds me of. Alright, in our last example, we have 0.4, 0.04, 0.004, and then a lot of you are like, oh, I know what the next one is, 0.0004, with 3 zeros after the decimal. But I do want you to realize what is actually happening here. We are actually dividing by 10 each time. Alright? So make sure that you understand the math behind it all. Alright, so you have a couple of blanks on your paper, and you need to make sure that you fill them out. So, first off, when several examples form a pattern and you apply the pattern, or you assume the pattern will continue, you are applying inductive reasoning. Okay? And also, a statement that you believe to be true based on inductive reasoning is called a conjecture. Keyword here is believe to be true. It could be false, but you're saying based on the evidence, I believe this to be true. Okay, that is a conjecture. Alright, so using inductive reasoning, first off, we need to complete the conjecture. It says the sum of two positive numbers is blank. Now, sum means to add. So let's pick two positive numbers. Let's say 2 and 4. That's 6. Alright, let's do another example. 4 and 3 is 7. And another example, 6 plus 9 is 15. Now looking at these numbers, 6 is even, but 7's odd. So I know it's not even or odd. However, I do see that all the answers are positive. So we can say that the sum of two positive numbers is positive. Alright, the product of two odd numbers is blank. Now product means multiplication. So you're going to multiply. Alright, so an odd number, 5 and 3 gives me 15. 3 and 7 is 21. Odd 9 times, what about multiplying it by -3 this time? And I get -27. So looking at these, I notice that they are all odd. Okay, they could be either positive or negative, but they are all odd. So completing the conjecture, I would say odd. Alright, given this table of values, you need to determine a conjecture. Alright, so taking a look at the females, they are 49, 51, 50, 48, 51, 47. So they're pretty long. And the males are 47, 45, 44, 46, 48, and 48. If I were to take the average of those two numbers, I would, sorry, not two numbers, the average of the 6 numbers for the females, oops, all 6, and then take the average of all 6 numbers for the males, I will notice that the average female is longer than the average male. So I'm going to write on average, female whales are longer than male whales. You could also say that male whales are shorter than female whales on average. That's fine. Okay? Now, when I have a conjecture, what happens is that you're going to need a counterexample to prove it false. Okay? So, I believe that you have this blank on your page. Make sure you're filling it out. But what we're going to do in the next couple of examples is find a counterexample. So, example number 8. Alright, we need to find a counterexample for the statement that for every integer n cubed is positive. So, what I would need to do is pick an integer that will give me, when I cube it, a negative answer. And what you're going to need to do here is actually pick a negative number. So, let's say negative 2. Negative 2 cubed will be negative 8. Now, this right here is my counterexample that proves this conjecture false. Alright, as a side note, when you're putting this in the calculator, make sure you put the parentheses. Okay, what happens if you don't put the parentheses is your computer thinks you negative 2 cubed, let's do squared, will give you negative 4 in your calculator, okay? Here's the problem. You know that negative 2 times negative 2 is a positive 4, so make sure that you put parentheses, and that way it knows, oh, you wanted to do negative 2 times negative 2. Then the calculator will give you the accurate positive 4. Alright, 2 complementary angles are not congruent. Now, complementary means that they add to 90 degrees. Okay, this is a vocabulary word from your previous math classes, so if you're not familiar with it, make sure that you write it down somewhere. Okay, so I need 2 angles that add together that equal 90, but that are congruent. Well, the only example we have is 45 and 45 degrees. So this right here is our counterexample to the conjecture that 2 complementary angles are not congruent. Alright, here is a table of values. We are still finding a counterexample. It says the monthly high temperature in Abilene, Texas is never below 90 degrees for 2 months in a row. Looking at this table, I can see that both January and February are both under 90 degrees, and it's 2 months in a row. So that right there is my counterexample, January and February. Alright, example number 11, and our last example for today, says that the radius of every planet in our solar system is less than 50,000 kilometers. Now, I want you to read this very carefully because the table is actually in diameters. Okay? What that means is I have to multiply this 50,000 by 2 to get 100,000. Because this is going to be the new diameter that I'm looking for. So basically, I'm looking for one example. There are 2 on this table that have a diameter of larger than 100,000. That would be Jupiter, and that would be Saturn, okay? You'll notice that Uranus is not an answer because diameter, well, I mean, technically the radius would be 500-ish, around there, okay? That is less than the 50,000, okay? So you have to be very careful about reading the table and reading the conjecture and seeing the units of measure, okay? It could have been in meters versus kilometers, and what they're actually talking about here. Alright, so that's all we have for today. We will be talking about deductive reasoning and logics in the following lessons. See you soon.